Hey, let's talk about the project. I'm not going to give you the answers, but I'm just going to talk through it with you so that you can find the correct answer. Now, they talk about origami, and it says it's a Japanese paper folding. It relies on properties of geometry to produce fascinating and beautiful shapes. For example, you can make a swan from a square piece of paper. The first figure in this illustration shows some of the creases for an origami swan that has been unfolded. Okay, so notice they took this square piece of paper and using origami they are able to create this swan. Here are some of the folds they created while doing this. Okay, it says ABCD is a square. DE bisects angle ADB. What does that mean? So DE bisects angle ADB. That means these two are the same size. Okay. DF bisects angle DBC. So where's DF? Here's the line from D to F. It cuts BDC in half. So these are also congruent angles. Okay. Now notice if this is a diagonal, it's cutting this right angle in half. So we end up with 4 equal angles here at this vertex. Use these facts to classify triangle ABD by side lengths and by angle measures. So let's take a look at where that triangle is located. There's triangle ABD. Okay, so what do we want to think about? Okay, so if you're classifying by its side lengths, remember the 3 possibilities are either scalene, meaning none of the sides are the same length, isosceles, meaning 2 sides are the same length, or equilateral, meaning all sides are the same length. Now, looking at it and remembering that this triangle is part of a square, okay, here's our triangle right here, how many sides would be the same length? Okay, so think about it. Think about a square, what we know about a square. Okay, what do we know about the sides of a square? Notice 2 of those sides are also sides of a square. So classify it by sides, so either scalene, isosceles, or equilateral. No sides the same, 2 sides the same length, or all 3 sides the same length. Okay, notice 2 of our sides are the sides of that square, and then we have the diagonal here. Okay, we also need to classify it by angle measure. So looking at that triangle, what do we know? By angle measure means either a right triangle and has a right angle in it, acute and has all acute angles, or obtuse and has one obtuse angle. So again, think about a square, think about the corners of a square and what their measures are. That would make this 90-degree angle. This is a square. So what would this be? Would it be a right triangle, an acute, or an obtuse? So your classification will have 2 words in it. One will be one of these words here. By sides, is it scalene, isosceles, or equilateral? And your second word will either be right, acute, or obtuse. It says in the previous example of the origami swan, find the measure of the angles in triangle EDB. So where is triangle EDB? Okay, so again, I'm just going to try and walk you through this. Now, in the previous example, we knew this was a square. So we would have a right angle here, 90 degrees here, and a right angle here. Notice this BD is cutting this in half. So if this angle is 90 degrees, what would this angle be if it's half of it? Fill that in right now. If this angle is 90 degrees, what would this angle here be if it's half of that 90-degree angle? Okay, next angle, let's find this one here. Now remember, in the previous part, they told us that these lines were bisectors, so we started with a 90-degree angle. This line cut that 90 in half, giving us what? And then this line cuts the angle in half again, so we had our 90 cut in half. Cut it in half again, and what would be the measure of this angle? Finally, we have our angle E here. Now remember that all three angles in a triangle add to be 180. By now you should know this angle. You should know this angle. Okay, so then you just say, well, how many degrees are left to add up to 180? Okay, so my angle E that I'm looking for should be my first question mark, my second question mark, add those together to be 180. You should know these values now, okay? If you stopped at each point, wrote down the values, then you can use them to find angle E. Okay, so that doesn't do the problem for you, but it does walk you through the logic and the steps you would use to solve